All right, today we're going to talk about literal equations. Literal equations are equations that just normal equations. Sometimes they have a few extra variables, but we're going to be solving in ways where we're not actually getting an x equals 5 as the answer, but rearranging the equation many times to be more useful to you, but not actually finding an absolute solution, but maybe just rewriting the equation in a different form. Okay, so in other words, we're taking an equation and we're solving for some given variable, not necessarily looking for a specific number. Believe it or not, you know how to do everything on it. If you just pay attention and try and don't get intimidated by the fact that you have multiple variables and it looks different, you should find it to be fairly simple to do and very useful to you. Now we're going to start with something that you know how to do, which is solving for x. I have this equation, 5 plus 2x equals 9. Now if you're going to solve that, you would look at this and start with that x and go, okay, the x is being multiplied by 2 and then having 5 added to it. So if I want to solve it, I'm just going to work completely backwards and opposite. I'm going to subtract the 5 and get 2x, and then the 9 minus 5 is actually going to be 4. But I'm not going to simplify that yet. But you know you would get 9 minus 5. The next step would be to divide by 2, and you get x equals 9 minus 5, all of that divided by 2. Now if you were to simplify that, 9 minus 5 is 4, 4 divided by 2 is 2. So x equals 2. Now I left it up there like that to show you that you can simplify in the end, it still works out for you. Because that's going to apply to what we do next. Here we have ax plus qj equals k. No numbers in it, but it looks very similar to the one we had above, which was 5 plus 2x equals 9. Here, though, we're going to be solving for j. Now again, same steps we did before. We look at j. J is being multiplied by q, and then having ax being added to it. So if we want to get j all by itself, in other words, we want j equals, we've got to get rid of the ax and the q. So we start by getting rid of the ax. We subtract it because it's being added. Now here's the awesome part about it. When we subtract it, ax minus ax is 0, so it's gone. But well, on the right side, we still have k minus ax. Now most of you are probably thinking to yourself, gosh, k minus ax, I don't know what to do there. Yes, you do. If you have 3 apples and you subtract 2 bananas, you still have 3 apples and 2 bananas, don't you? You can't simplify that any further. It's just k minus ax. So k minus ax is k minus ax. There's nothing you can do about it. Okay, you can't simplify it. Well, now you still have the qj, and you're looking for j by itself. The q is multiplying it, so you would divide by q. Well, q divided by q is 1, so you're left with j. Now on the right side, you have k minus ax, the whole thing being divided by q. There's nothing more you can do to simplify it. So j is equal to whatever k is minus ax divided by q. Now you probably look at that and go, well, that's just a bunch of letters moving around. But if that were a formula, you've rewritten the formula, and you're going to see this in a minute. You've rewritten the formula in terms of j. Here are a couple of formulas that you will use or have used. The first one, we have distance equals rate times time. Now that one's really easy to do if you know, let's say the rate is 40 miles per hour and you travel for a total of 3 hours, then that means that your distance is 120 miles. Everybody gets that. But what if you know that the distance is 120 miles and you know the rate is 40? Well, then you could solve that to find t. Okay? But you could also rearrange this entire formula so that you have a second formula, and that's simply to solve this for t, you would divide by r, and now you know that time is whatever the distance is divided by the rate. You can do the same thing if you need to know the rate. Take out the t, and the distance divided by the time is equal to the rate or the speed. So from that you have found new formulas. You have the formula for distance, You have the formula for time, and you have the formula for the rate or the speed. 3 different formulas. Next, we have ax plus by equals c. That is the formula, or that is the standard form of a linear function. But this alone does not go in the calculator. So to put this in the calculator, we would have to have y equals form. That's the easiest way. Well, what we can do is we can take this equation, ax plus by equals c, and we can solve it for y, meaning we get y by itself. So we're going to do the same steps we did before. We're going to start by subtracting the ax because it's being added. Okay, so we end up with by equals negative ax plus c. Now I write negative ax plus c because it looks like mx plus b. If you wrote c minus ax, that would be perfectly fine. So now we have by equals negative ax plus c. We're going to divide by b. When we divide everything by b, it looks like this. The b's cancel and we get y equals negative a over b x plus c over b, which should look very familiar to you because it's on your flip book. The slope of the line is the variable, or the coefficient in front of the x, which is negative a over b, and the y-intercept is the constant, the number by itself. So by taking the standard form of a linear function and solving it for y, which is slope-intercept form, we now have a formula to find the slope and the y-intercept, which we can use at any time now. Luckily, I gave it to you in your flip book. So let's look at a couple of these. Here we have 3x plus 2y equals 8, and we're going to solve that for y, meaning we'll be able to put this in the calculator. Okay, so we're solving for y. Start by subtracting the 3x, which is going to give us 2y equals negative 3x plus 8. Next, we're going to divide by 2. Now when we divide by 2, the 2's cancel. We get y equals negative 3 halves x plus 4. So we now have the slope and the y-intercept. The one on the right, we have 4x minus 12, or 4x equals negative 12 plus 5y. That doesn't look like any form we know, but we still want to put that in the calculator, so we're going to solve that one for y equals as well. So that means we want to get this all by itself. So the same steps apply. We have times 5, we have adding negative 12. So the easiest first thing to do is just add 12. And now we have 4x plus 12 equals 5y. Next, we want to get rid of the 5. So we solve for 5, divide it out, then cancel, and we get 4x, or 4/5 x plus 12/5 equals y. Now we have an equation that we can put in the calculator if we need to. Now if you're thinking about how would we actually graph this equation if we needed to, that's where using our smarts comes back in. We now know the slope is 4/5. We know the y-intercept is 12/5. 12/5 can be difficult to graph. So go back to what you know before. Use this information, 4x equals negative 12 plus 5y. It's not in standard form. You could actually rewrite this in standard form if you needed to. You have 4x equals negative 12 plus 5y. If you subtract the 5y, you have 4x minus 5y equals negative 12. Well, you know what the y-intercept is going to be, so you don't need to cover that up. But if you cover up the negative 5y, then that tells you that x is negative 3. So now you have the x-intercept, you have the slope, you have the y-intercept. You've got 3 pieces of information. Use what you need. Go graph. I would probably use this, the slope, and this, the x-intercept. Okay? So again, rearranging the equations to make them useful to you is what this is all about. So you don't have to memorize a multitude of formulas, memorize one and learn how to move things around, or take equations like these two and make them much more easy to work with in the ways that you already know. So anyway, come in with questions and get ready to go.